Alright, welcome to the next video on exponential functions. Today we're going to be talking about topic 5. We're going to look at part 2 of our graphs of exponential functions. Alright, once again, these are the standards and the objective for today. There's two things that I want to focus on. The first is the first standard, part C. We want to be able to use the properties of exponents to transform expressions of exponential functions. So we're going to be given a exponential function that we want to transform into a new format. And the reason we're going to do that is for our second key, which is to be able to write a function defined by an expression in different but equivalent forms to find the different properties of that function. And in our specific case today, we want to be able to rewrite exponential functions so that we can identify the y-intercept and the common ratio. All right, so we want to be able to take what we know about integer exponents and rewrite expressions so that we can kind of identify the different key features of a graph. So sometimes we can use the properties of exponents to easily sketch exponential functions. How can we use the properties of exponents to sketch the graph of y equals 2 to the x plus 2 power? And so we're going to be referring back to our rules for exponents, but we're also going to be keeping in mind that for an exponential function, we want to be able to write it in y equals a times b to the power of x, where a is our y-intercept and b is the common factor or the common ratio. Okay. So right now, y equals 2 to the x plus 2 power is close to y equals a times b to the x, but we've got too much going on here with x plus 2. It needs to be just x. So let's think about what we know about our exponent rules. One of the rules for exponents said that if I have two powers, let's say x to the a times x to the b. So in this case, I'm multiplying powers with the same base. They both have a base of x. In that case, I could combine these two by adding the exponents. So x to the a times x to the b became x to the a plus b. Well, the same would be true if we wanted to go the other way. If we were given x to the a plus b, we could split that up into x to the a times x to the b. Well, that's what we have here. We have 2 to the x plus 2. So this could be rewritten as y equals 2 to the x times 2 squared. Because if I were to, they both have a common base of 2, so I would have added these exponents to combine it into one expression. We took it apart because we want to be able to see this equation in y equals a times b to the x. All right, so let's simplify this a little bit. We've got y equals 2 to the x, and 2 to the second power is 4, so 2 to the x times 4. So now let me use the commutative property to just change the order around here. So I've got y equals 4 times 2 to the x power. And when I do that, I've now written this expression, this equation, in y equals a times b to the x power, where I see a is 4 and b is 2. Okay. So now I know the key features of the graph. I can sketch what that graph is going to look like. So a is 4. A is my y-intercept. So I'm going to go on the y-axis to 4 and put a point. Okay. And let's go over here. We're going to make a table for x and y just to kind of come up with an idea of what the behavior of the graph is. So I know that when x is 0, y is 4. That's my y-intercept. The common ratio tells me how the y value is changing compared to x. So it tells me that the next term should be 2 times the first term. So if I had 4, the next term is going to be 4 times 2, which is 8. So for x is 1, I'm going to go up to 8 and put a point. All right. If I were to keep going, 8 times 2 would give me 16, which is off of my graph here. My graph only goes to 10, so it would be way up here, something like this. way off the graph. So since I ran out of room on this side of my graph, let's go backwards. Instead of x is 0, let's go backwards 1. So let's think, what would I have to multiply by 2 to get 4? Well, that would be 2. 2 times 2 is 4. So that means when x is -1, y is positive 2. And the term before that, what times 2 is 2? 1. So half before that was 1. And the one before that, what times 2 makes 1? Well, that would be 1/2. So when x was -3, y was 1/2. And we would keep getting less and less on this side of the graph. So let's take a quick sketch as to what this graph is going to look like. Oops. Let me erase that there because I don't want you to think that the graph actually goes below 0. So let me try that again. So it goes towards 0, but it doesn't cross the x-axis. Right? So notice it's still got that same shape that we've had in the previous lesson with exponential functions. So this is y to the 2x plus 2, or we said that was the same thing as 4 times 2 to the x power by using what we know about integer exponents. We were able to rewrite the expression. We broke apart x plus 2 as an exponent to 2 to the x times 2 squared. Multiplied 2 times 2, got 4, so my a term was 4, my b term was 2, and then we were able to sketch the graph from there. All right, let's try another one. We've got, using the properties of exponents, we want to rewrite y equals 3 to the negative x so that it's in our form of y equals a times b to the x power. Right? So let's think about what negative x means. So we've got y equals, move it down here, y equals 3 to the negative x. Well, how do I get negative x? Well, let's think that is -1 times x, right? Because I want x to be a positive value or positive variable. So negative x becomes -1 times x. And now let's think about our rules for exponents. Which property has me multiplying powers? Well, that's if we had a power raised to another power. Right? If we had x to the a then raised to the b, I would multiply a times b. Well, that's what I'm doing here. I'm doing -1 times x. That means that this could be rewritten as 3 to the negative first and then raised to the power of x. Okay, so now we've got y equals 3 to the negative first to the x power. Let's take one more rule. What do we know about negative exponents? Negative exponents become positive when I flip it or create the reciprocal of that expression. So x to the negative a becomes positive if I put it 1 over x to the a power. So 3 to the negative first is the same thing as 1 over 3 to the first to the x power. And 1 over 3 to the first is the same thing as just 1/3 to the x power. Okay. So I've been able to rewrite my equation here, and now it's y equals 1/3 to the x power. And if I want to write this in y equals a times b to the x, since there's no a term visible, it's understood that that means that's 1 times 1/3 to the x power. So what does that tell me? It tells me that my a value is 1 and my b value is 1/3. And remember, a is the y-intercept. So for a, I'm going to go put my point at 1 on the y-intercept. All right, now let's make a table so that we can kind of sketch some other points on the graph. So when x was 0, y was 1. My common ratio is 1/3. So as I move forward on x, I do 1 times 1/3, which would be 1/3. So when x is 1, y is 1/3. And we go again, times 1/3 would give me 1/9. So my next term is 1/9. And we could keep going, but you see those numbers are getting really small. So let's go the other direction. -1. Well, what had to be before if I multiplied by 1/3 and I got 1? Well, 3 times 1/3 is 1. So the term before 1 must have been 3. And before that, what times 1/3 is 3? That would be 9. 9 times 1/3 is 3. So up here it's 9. So this is what our graph looks like for 3 to the negative x power. All right, we were able to rewrite it into this form here, y equals 1 times 1/3 to the x power by using two rules for exponents. We broke apart negative x into -1 times x, which made the expression 3 to the negative first to the x power. Then using what we know about negative exponents, we flipped this and it became 1 over 3 to the first, or just 1/3 x. Okay, so now it's your turn. Go ahead and try this next one here. You're going to take y equals 2 to the x minus 3. Remember, you want to rewrite it so that it's in y equals a times b to the x power using what you know about exponent properties. So pause the video and then come back when you're ready to see what the graph looks like. Okay, so let's take the equation y equals 2 to the x minus 3. What do we know about exponents when we are subtracting them? If I had x to the a minus b power, what property allows me to subtract the exponents? Well, that's what happens when I am dividing powers with the same base. If I had x to the a divided by x to the b, I would subtract those exponents. So since I'm subtracting x minus 3, that means I must have had the expression 2 to the x power over 2 to the third. The same base is 2, and then I subtract x minus 3 because x is the power in the numerator and 3 is the power in the denominator. All right, well, let's take this a step further. Let's continue simplifying this. We've got 2 to the x power, and in the denominator I've got 2 to the third. So that's 8. 2 times 2 times 2 is 8. So now our expression, or our equation, is y equals 2 to the x power over 8. Well, let's think about what this expression means. If I'm doing 2 to the x power, what am I multiplying by 2 to the x if I've got 2 to the x over 8? Well, 2 to the x would be multiplied by 1 over 8 to get this expression here. All right, so I split apart this fraction, 2 to the x over 1, and 1 over 8 would get me 2 to the x over 8. So now let's use the commutative property again to rewrite this expression so that's in the right form. So we've got y, commutative property says I can do 1/8 first, times 2 to the x power. And now my rewritten equation is in y equals a times b to the x form. So a is 1/8 and b is 2. So since a is 1/8, that's my y-intercept. So I've got to try to squeeze 1/8 onto this graph here. So it's way down here by 0. Okay. And now let's try to make a graph, or make a table, to find some other values on our graph. So x and y. I know the y-intercept is 1/8. 1/8. And I know my common ratio is 2, which means I'm multiplying by 2 to get the next term. So 1/8 times 2, right? 1/8 times 2 would be 2/8 or 1/4. So it's 1/4. So it's a little bit above where 1/8 is. Right? To go to the next one, 1/4 times 2 would be 2/4 or 1/2. So 2 is here at 1/2. If I multiplied by 2 again, that would give me 2 over 2 or 1 whole. So 3 is 1. If I doubled the next one, 1 times 2 would be 2, then 2 times 2 is 4, 4 times 2 is 8, and so on. Okay. So let's connect this graph here. Connect all these points with a curve. Okay, and so that's what our graph looks like of 2 to the x minus 3. Right, we took 2 to the x minus 3, and using what we know about subtracting exponents, we changed it into a fraction, 2 to the x over 2 to the third. Simplified 2 to the third to 8, so it's 2 to the x over 8, then split apart that as two fractions, and that allowed me to see that my y-intercept was 1/8, and my common factor was 2. So I started at 1/8 at the y-intercept, and I doubled it each term on the graph to get the next value on the graph. All right, so go ahead and pause the video and try number 1 here on this section. So you're going to fill in the multiple choice as you go through this statement here. So take the graph that represents the function f of x equals -3 times 2 to the x, and then choose the correct choices here, and then come back and we'll check. All right, so the graph that represents the function f of x equals -3 times 2 to the x, well, that's written in y equals a times b to the x power. So a in this case is -3 and b is 2. Remember, a is my y-intercept. So this function has a y-intercept of, since a is -3, the y-intercept is -3. And the graph is increasing by a common ratio, that's by b term, so the common ratio is 2. Now what's happening with the graph is decreasing as what happens and approaches 0 as what happens. So let's just make a quick sketch so that we can see. If we're not sure, always make a sketch so that you can see what's happening with the graph. All right, so I know my y-intercept is -3, so a -1, 2, 3. Okay. And as I move to the right on my graph, I'm multiplying each previous term by 2. So I would do -3 times 2 to get the next one. So that would be -3 times 2 is -6. So for x is 1, I'm at -6. For the next one, it would be -12. So it's getting more negative as we go along. Right, so the graph is decreasing as x increases. Right, so as x gets bigger, y is getting more negative. Right. Then I go the other way. It's approaching 0 then as x is getting less, as x is getting more negative. So this is just a quick sketch as to what this graph would look like, y equals -3 times 2 to the x. All right, for part 2 down here, let's work through this one. What we're doing is we're seeing which of these expressions here is the same, can be written in the same way as y equals 8 times 2 to the x, or f of x equals 8 times 2 to the x. All right, so if I take that expression, y equals 8 times 2 to the x power, right, I know a is 8 and b is 2. So I want to see if I get the same thing with any of these other expressions. So we're going to have to go through each of these, right, using what we know about our rules for exponents and see if we have any equivalent equations. So the first one, y equals 2 to the x to the third. All right, since I'm raising this power to another power, I can do 2 to the x times 3, or 3x. And then I could even rewrite that again as 2 to the third to the x power. So all I really did was just switch the location of x and 3, which I can do because multiplication is commutative. Right? The order doesn't matter. I can do 2 to the x and then to the third, or I can do 2 to the third and then to the x power. Well, 2 to the third is 8 to the x. So this equation is y equals 8 to the x. Is that the same as what we had originally? No, this is 1 times 2 to the x. So in this case, a is 1 and b is 8. So the first one is not the same equation. All right, let's look at the second one. 2 to the 4x. Pretty similar to the first one. This is 4 times x, so I can rewrite that as 2 to the fourth to the x power, and 2 to the fourth would be 2 times 2 times 2 times 2, or 16 to the x. All right, so if that equation is y equals 16 to the x power, a is still 1 and b is 16. Either way, it's not going to be equivalent to my first equation. All right, we look at the next one, number 3 here. We've got y equals 2 to the x plus 3. So since the exponent is being added here, that tells me that before I was multiplying two powers with the same basis. 2 to the x times 2 to the third could be combined as 2 to the x plus 3. So if I simplify 2 to the third, that's 2 to the x. 2 to the third is 8. So y equals 2 to the x times 8, or I could write that as 8 times 2 to the x. So a is 8 and b is 2, and this third expression is the same as the first one, y equals 8 times 2 to the x. All right, so this one is equivalent. All right. The next one we've got is, go over here, y equals 2 times 2 to the x. Okay. So if I've got 2 times 2 to the x, that 2 to the x could be split up. So that could be 2 times 2 squared to the x power, which would be 2 times 4 to the x. So in this case, a is 2 and b is 4. So it's not the same as my first equation. All right, and now we've got one last one to check. Y equals 4 times 2 to the x plus 1. All right, and just like that third equation, since I'm adding the exponents, that means that I must have had 4 times 2 to the x times 2 to the first. I must have had bases that were the same to add the exponents. Okay, so let's think about what we've got here. We've got 4 times 2 to the x times 2 to the first. Well, using what I know about the commutative and associative properties, I can rewrite this as 4 times 2 times 2 to the x, or 2 to the first if you know that's the same term. 2 to the first is just 2. Right? And then 4 times 2 is 8 times 2 to the x. So here a is 8 and b is 2, and now this equation is the same as my original one, which means this one was also an equivalent equation. All right, so this is just another way to show you how you can use what you know about exponent properties to rewrite different exponential equations. Right? Because sometimes the equation is not written in y equals a times b to the x. sometimes that form is hidden and we need to be able to rearrange things to identify the y-intercept and the common ratio for a specific exponential equation.